All right. So, welcome to this session. Continuing for QBlade for ME174.1. So, this is a completely new exercise, or rather, completely new data set. We'll be replicating a certain study from 2011 sa galing Norway. So, ito yung experimental setup nila. Medyo cute. Like, parang siyang microphone stand na may blades. So, it's a very small room and meron siyang pinaspecify na at least a few parameters na usually hindi mo gagalawin sa QBlade because of the spacing. Yes. Itong study na to from 2011, it has experimental data and it has X-foil na ginagamit ng QBlade saka K-omega modeling. It they try to compare yung results nung dalawang models for different free stream velocities. So, pakita ko lang. Ito yung result ng kanilang study. So, this is an X-foil, X-foil test for one of their airfoils. Ang gagamitan talaga natin is ito, this top legend. And kinompare nila ito with respect sa Fluent using an SST model and RNG model respectively. Yung end na parameters na na-record nila, which is figure 12 sa model na to, ito yung I believe yung final outcome nung comparison nila. So makita ninyo, meron tayong power coefficient curve with respect to tip speed ratio. Meron din tayong thrust coefficient with respect to tip speed ratio. Before I forget, alam nyo ba yung terms na power coefficient and thrust coefficient? May I see a raise of hands kung alam ba ninyo or hindi? Please let me know. Kahit reactions lang sa chat or sa meeting. Question is, do you know what the power coefficient and thrust coefficient are with respect to turbo machinery? Is it a yes or a no? Hello. Power coefficient. Okay, so some familiarity, mukhang seems like hindi lahat familiar. How about tip speed ratio? Have you heard of the tip speed ratio sa turbo machinery? I think yung tip speed ratio kasi is more niche than the coefficients mismo. Are there people na familiar sa tip speed ratio? Okay, medyo hindi. Okay, so I'll type out yung meaning ng tip speed ratio. The tip speed ratio, which is lambda, in the x-axis here, ito yung ratio nung pinakamabilis na takbo ng blade tip mo with respect dun sa free stream velocity. So this is the ratio of the blade tip speed with respect to the free stream velocity. So yung free stream velocity, ito yung velocity ng hangin na papunta pa lang sa turbine pero it's not very close. So you can think of it as yung ad infinitum na velocity ng hangin. So when we're evaluating turbines, or at least wind turbines, madalas kino-compare yung power coefficient saka tip speed ratio. So for every tip speed ratio, isipin nyo na lang na kapag tumataas yung tip speed ratio, bumibilis yung ikot ng wind turbine. Sir, pwede ba, so ibig sabihin nun, pwede ho bang i-constrain yung bilis ng turbine or i-fix yung speed? Yes, pwede ma-constrain yung speed ng wind turbine kahit na mabilis or mabagal yung hangin. Merong mga mechanisms doon. We will not cover that. Pero yeah. So, kapag binibilisan mo, yung turbine, nagbabago, yung napoproduce niyang power ay yung napoproduce na thrust nung turbine rotor. And this is normalized through the power and the thrust coefficients. So, etong ano na to, yung solid, or rather yung mga dots dito, these are the experimental data. So, binari nila yung tip speed ratio in their setup, and ito yung curve na lumabas. Yung solid line, that is from the blade element momentum model, which is yung ginagamit ni QBlade. And ito naman, yung mga check mark, ito yung lumabas for Fluent. I need to check kung ano yung ginamit nila for I'm assuming na SST kay Omega model yung ginamit nila kasi mukhang mas malapit yung SST kaysa kay RNG. So this is for the power coefficient. That is for the thrust coefficient. Um, After this session, magpapadala ako ng image saka ng digitized data points for the experimental data para ma-compare ninyo. Ngayon, there are some things that you can see. Um, hindi, yung dalawang models, yung SST model galing kay Fluent and yung BM model galing sa yung BM model, they don't have a good accuracy after they exceed a certain tip speed ratio. Like for here, makikita nyo, up to tip speed ratio of 6, medyo malapit yung mga graphs respectively. And then nagde-deviate sila. Like nag-overestimate na sila nung power na paproduce nung aircraft, nung turbine rather. Sa thrust, um, Fluence SST modeling comes closer a little bit. Yung BM model, it kind of underestimates yung napoproduce na thrust ng ating propeller. At least for most of the range na underestimate niya. Ang question na gusto natin masagot is based dun sa updated modeling ng QBlade, will the program output the same kind of overestimation and underestimation, or ganun pa rin ba yung state niya? So if you recall, si QBlade, it started with using the blade energy momentum model, pero it started to amend some of that, nagdagdag pa sila ng mga additional models to compensate for the inaccuracies of the BEM model. So yun yung tatest natin for today. So okay. For context, if you see yung inyong QBlade file, okay, balik tayo dito. Makikita nyo may naka-drawing na airfoil. So this airfoil is NREL 6268. Ang ginawa nila for the wind turbine blades is that pare-parehong airfoil na lang yung ginawa nila. So the airfoil is the same, pero nag-shrink siya, tapos nagbabago rin yung twist niya. So, sir, bakit may circle? This is for the base. Yeah, this is for the base ng ating turbine. Although, if you, kapag tinignan mo na, where it counts, only base 3 yung magka-count. So, these are yung cylinders na attachment points nung turbine. Malit lang yung contribution nila, pero yeah, sure, why not? Pwede natin siya isama. The next thing that you'll notice as well is sa airfoil analysis, sa polar analysis, you have your bases and you have your NREL. If you select NREL, makita mo, oh, shoot, ang dami. Ang dami niya. So, let's see, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 22, 23, 24, hanggang 30 siya. So, 30 slices na NREL 6268. To give context, buksan ko lang yung file ng spreadsheet. So, ito siya. Ito yung laman ng file. So, makita mo yung number. This corresponds to one row in that number. So, pag nakita nyo, NREL 6268 number 4, this that row. It's that row. Ito siya. Saan galing tong file? Saan galing tong data? It comes from the study itself. na-reconstruct ko siya based on information na available, which is, wait lang, scroll up. Ito siya. Yeah. So, ito yung supposed na itsura na makukuha nyo after this activity. Kung makompleto nyo to, yeah, it's 30 rows, unfortunately. So, normalized pa to. In-adjust ko na siya based on certain assumptions. It might be incorrect, pero it's what we can work with. So, yung first column is radial position with respect to the maximum radius. So, para siyang normalized na radial coordinate. Yung C over R naman, that is the chord length with respect to the maximum radius. So makita nyo sa Excel file, computed na siya dun sa pangalawang box ng data. Yung alpha naman, this is the angle of attack. So makita nyo may negative ka na angle of attack. Which is, yeah. It can happen. It can happen. So yeah. Okay. Knowing that, sir, may gagawin pa po ba tayo dito sa ating polar files? Please ignore this, yung nasa ilalim. I feel like fluke to. So right now, I'm going to render only 3 para medyo mabilis tayo. I'm going to render si number 4. No, I'm going to render one of the bases, base 3. Base 3 lang actually yung kailangan natin out of all the bases. Si base 3, I will render it. Also, I'll render number 4, 4, 5, 20, and 30. So, 5 lang yung i-render natin for today. So, okay. If you can follow, let's stay in this module muna, sa polar module. Mapapansin nyo if I only show the current polar curve, walang curve si base 3. I've tried to look for a solution for this, pero I feel like hindi siya ganun ka-relevant either way. You can still do your you can still commit your blade design even if kulang ka ng foil. So that's all right. Let's skip base 3. So ngayon, punta tayo kay 4, 5, 20, and 30. 4, 5, 20, and 30. So yeah, punta muna tayo dito. Show current polar curve. So ito siya. This NREL 6268 number 4, it corresponds to the fourth row. Fourth row of our blade. So ito ang gagawin natin. We will edit our polars kasi nakalimutan ko ilagay yung Mach number. So mapansin nyo dito, nakaset na yung Reynolds. So if you see here, let's go to number 4. So number 4, Reynolds, it is, eto na, this 53905, which is correct. Pero ilalagay natin yung Mach number, which is 0.04 in this case. Yung encrypt natin, as specified by the 2011 study, they estimated the encrypt to be 3. Yung reasoning nila is found in the study itself. Hindi ko pa siya masyado maintindihan. Pero yeah, it has something to do with the restriction of the wind tunnel kasi medyo malit siya for as per their analysis. So pag nakita nyo may Mach number na, yung isa sa mga polar profiles, so like for example dito, 0.04, that's good. Wag na natin sila pakialaman. Next, punta tayo kay 5. So si 5 corresponds to row 5. So makita natin dito, yung Reynolds nandyan na, pero yung Mach number, oh shoot, wala pa. So dito, we're gonna do is just enter yung appropriate na Mach number. So row 5, it's 0506. Then let's just click create. Okay, overwrite. So yes, pag in-overwrite mo, mag-generate siya ng bagong curve. So, once you've set up yung Mach number, just create and overwrite everything, then start analysis. So, yan. Okay. So, maganda is very smooth yung curves. Before nagkakaproblema ako kasi nagkaka-jagged data points, nagkakaroon ng outliers. If you have jagged data points sa ilang angle of attack, that is bad. Kailangan malinisin yung data mo or at least i-refine yung part of the mesh, essentially. So, eto na yan. So, it's number 5. Let's go to number 20 naman. Can follow ba pala? Can follow naman sa gagawin. Okay. Yeah, let's go to row 20. If we press edit dito sa baba, you'll see na appropriate na yung Reynolds, pero yung Mach wala pa. So let's put the appropriate Mach. It's 12302 if I'm tama yun basa ko. So create, overwrite, then start analysis. Okay, nice. So yan, meron na tayong medyo mas okay na uh, number 20. Next is yung last, pinaka-last. Muna tayo kay 30. Sa last one, so makita natin, pasok na yung Reynolds, pero yung Mach number, let's adjust 0.17131. Well, technically, 0.17 is okay na kasi tinatrunket ni QBlade to 2 digits lang yung Mach. Alright, start analysis. Let's go. Whoop. So, pag nakita mo may jagged areas for now, let's ignore, let's assume na okay siya. Like, kunwari everything's fine. Nothing's wrong. Mahirap ayusin tong curve because we are developing every curve from a single NREL file or 6268 single airfoil file. Kapag gusto mo i-refine to, you have to refine the blade element or the curves mismo, which is hindi na natin natatakal for this session. Pag nakita niyo may curve, hayaan niyo na lang. Fingers crossed it's not a very wild deviation. So, so far is everybody good? Naka-follow naman. So, kahit 4, 5, 20, 30 muna para lang maka-follow tayo. If naka-confuse pa kayo, you can do at least 4 and 30 para umokay kayo. Medyo may mabuo tayong blade, essentially. So, if okay na kayo, please let me know. Kahit check, react yes lang sa inyong meeting tab. Just let me know. If naka-follow kayo, just select, just react yes. Okay, good na, natapos niya na. Alright. So there's three. Antayin ko na lang kayo para makasunod. So that's 3 out of 14. 3 out of 14. Meron pa ba? May hahabol. Disclaimer, baka iba yung results or at least itsura ng results sa QBlade ninyo. So it's possible na nag-X-file analysis kayo, biglang wala to or either lumala or lumipat yung outlier. That's okay. Okay lang yun. It's pa eh. Pag tinry natin linisin to, maglilinis tayo ng 30 airfoils which is Medyo masakit sa ulo. What we're doing right now is just a shortcut validation of the QBlade method. So, hindi necessary na kailangan natin linisin lahat. Hindi naman natin ito i-submit sa peer-reviewed journal. Okay, may ilan pa ba? Meron pa bang nawala? If nawala kayo sa along the way, please let me know. So far, I think apat na yung nag-yes. For the others ba, wait, meron ba kayong laptop na may keyblade ngayon? Curious. Or because of the limitations of your device, hindi nyo maran pareho ng maigi. Okay. So, I suppose apat. If nalito, medyo nalilito pa kayo or you need time, you can just do yung dalawang dulo, yung 4 and 30. Tapos, I'll be going ahead na dun sa next module na hindi natin naabot. So, okay, let's go to the 360 extrapolation module. This is the part where from the -15 to 25 data points, degrees of data points na na-generate natin, mag-extrapolate tayo ng 360 degrees na lift, drag, and pressure coefficient data. So, sir, bakit kailangan na i-extrapolate pa? Hindi ba pwedeng iset na lang natin dito sa polar na 360, -180 to 180, let's say? I believe it's because may limitations yung X-foil model as is in replicating the full 360 degrees pressure coefficients. At least yun yung pagka-gets ko. May certain limitations siya. It might be advisable to use a different modeling approach like what we have here in order to extrapolate yung natitira pang angle of attack values. So right now, I'll go to 4 muna. Yeah, NREL 6268 number 4. Yung pala, yung mga bases, yung 1, 2, 3, wala ka ma-generate na extrapolation dito kasi wala na generate si Xfoil na data for them, and that's all right. Tinest ko na to kagabi. It will still run kahit na wala siyang proper Xfoil data. So yeah, you see here, dito nakalagay yung pangalan ng polar. So it's showing us the polar right now. And makita natin dito sa first subsection ng ating module, we have this thing called Create 360 Polar. You have two existing models. Ang default ngayon na setup ko is Montgomery model na setup. Right now, you don't need to know the exact details of either of these. Let's follow Montgomery first. And makita natin there's no other option except extrapolate. Okay, so right now, if you're here, select NREL 6268 number 4, yung inayos natin, and click extrapolate. So if you see click extrapolate, oh, okay. So yung red marks, these are the extrapolation points. Ito yan. And makita mo may mga fine-tuning tayo. So ano yung relevance sa mga bawat sliders dito? So it's a little more complicated. It's beyond the undergraduate discussion. Or kung gusto niyo mag-thesis dito, you can try to investigate this. Or I'll show you what happens if I try to move A+. So if I move A+, something kind of happens. Something happens. Makita niyo dito yung gap dun sa lift coefficient natin, nagko-close. Ang goal natin is to close yung discontinuities as much as possible between the curves. So makita niyo dito, as I'm adjusting the A plus slider, may point na lalapit siya. Like, magko-close yung discontinuity ng slide pero it's not that much. If I try to move B plus, may weird na nangyayari. Oh, okay. So see here, if I move B plus, eventually magko-close yung discontinuity dito sa lift coefficient. So yeah. So as much as possible, we remove yung discontinuities between the X-file data and the extrapolation. Yung A minus naman, it has something to do with the other side, yung negative part of our X-file data. So makita mo, if I move this slightly, medyo like there's a sweet spot. Like hindi yan nako-close yung discontinuity as is. Especially dito sa baba, sa drag coefficient, like wala, like nothing really happens. If we just B minus, hindi masyado. Like very felt nararamdaman siya sa lift pero hindi siya nararamdaman masyado sa drag. So try to parang medyo tansya-tansya lang talaga siya. Try to ensure na yung lift coefficient curve ay as continuous as can be. Yung drag, sad. We can sacrifice the drag data for a bit. But yeah. So if okay na tayo dito, we can click save. And if we click save, makita mo, may 360 polar na tayo. It has the name of our polar, which is 6268 number 4, pero may nakalagay na 360M. Yan yung pan-distinguish nyo nung 360 polar. So, yung blue na to is our X-file data. Yung red naman is our Montgomery extrapolation. So now, what I'm gonna do is to do apply, rinse, repeat sa 5, 20, and 30. So, ganun number 5 now. I'll leave you to do the rest as is. So, I'm just gonna do this live. If you wanna follow along, go ahead lang. So, right now, I'm gonna click extrapolate again. Parang mas maganda yung data dito. Like, mas maganda yung extrapolation. If you see here, if I adjust A plus a little further, nagbe-break apart na. So, this, yung estimation ni Montgomery is kind of good. It's good. So, let's not, una natin galawin sa yung, mga plus na sliders. For the minus side, let me see if I can try to make this a little smoother. So, if kapag nag-spike siya dito, like, nag-increase kasi yung discontinuity and medyo hindi okay. It's kind of okay. Kahit hindi tayo pareho ng settings, that's all right. Part of the process. Again, we ignore the drag. And right now, I'm gonna click save. Yeah, okay. So now it is saved. Next is number 20. Number 20. Extrapolate again. Oh, okay. So, slight adjustments lang siguro. Okay. Well, slight adjustments. Dito sa baba. All right. So, it kind of looks good. So, save na. All right. Next is number 30. Let's extrapolate. Unfortunately, yeah, may dip tayo. And it looks good na. As is, I think yung E minus could be better, but I think this is good. So let's just click save. So that's 4, 5, 20, and 30. How are you doing so far? Okay ba kayo? May questions ba kayo with regards sa um, steps as to what this exactly means? Meron documentation si QBlade. So like, wait. So as to the meaning of the polars, yung mga plus saka minus, yung slope, yung CD90, this is a default drag value at 90 degrees. So there are some parameters sa Montgomery. QBlade does not exactly go deep into the explanation. I think merong paper or reference that would explain this more properly, pero we're not equipped to cover yung modeling specificities or yung mga fine details of this model. Nung time namin sa turbo machinery under Sir Danao, he did not exactly explain all of these. He explained it the same way I explain it to you now. So, papagandahin mo lang yung curve, essentially. And right now, I trust that QBlade's default settings are beginner friendly. So, noong time namin, beginner friendly din ang QBlade. So, yung mga default settings niya, those are the settings that would make for the best possible models, or rather, the best possible output for general case. If you get good in blade element modeling and yung mga other models na ina-apply ni QBlade, you might be freer to freestyle in the models. So, okay. Can everybody, is everybody good sa 360? Like, klaro naman. You good? Medyo ano lang siya. Okay, nice. That's good. I have some confirmations. It's kind of confusing, or rather, it's parang nakakalula siya kasi like a, you're using a software and you don't quite know all of the things that are underneath the front end. And that is a common work experience sa engineering. Depende kasi sa kumpanya nyo, especially kapag nasa planta ka or sa design, minsan hindi consistent yung mga companies sa software na ginagamit nila. For design companies at least, merong consistency in that they have a preference for SolidWorks and ANSYS modeling. For for the plant sector, I am not sure kung consistent sila sa gusto nilang software. And yeah, minsan ganun. Sometimes mapapasabak ka talaga, especially for design companies na mababa lang yung experience mo sa SolidWorks saka sa ANSYS because let's say yung thesis mo hindi naman siya hindi naman siya pumunta in that direction or ibang klaseng ANSYS yung pinuntahan mo. That's all right. Sometimes yung kailangan mo lang malaman is yung how the software works. That's effectively good na. Pero if you want to level up, siguro pagdating na lang sa trabaho, pag na-realize mo na kung saan mo gusto mag specialize or let's say mag level up, siguro that's the time ideally na magma-masters ka na. Or if wala kang makukuhang trabaho, pwede ka naman mag-apply for DOST ERDT, or rather not DOST pala, ERDT scholarship, tapos mag-MS ka na lang. Essentially, sisweldohan ka nila para mag-aral ng masters. Yes. Yun nung time namin medyo siya, maraming kumagat dun sa offer. May joke nga kami nun before. Pag wala kang mahanap na trabaho, masters ka na lang. Sisweldohan ka naman. So, humor aside, let's go to the next module, which is the blade design module. So this is what it looks like. There are some things that I want to share sa blade design module. I can't see it right now kasi hold on. Accumulated. What? Let me just stretch a little. What? Yan. Okay. Oh, it's not showing me. Okay. So makita niyo sa window, sa menu bar, may tabs for every module. So if you change tabs, may magbabagong tab dito. So here we have a blade design module. So create a new blade, edit blade, delete blade. If you look at the export data, there are some things na could interest you. So that BLD is, actually, I'm not sure kung saan siya nagpa-plug in, pero it might be a useful file format sa turbo machinery software na hindi pa natin alam. Including this, yung Aerodyne V13 format. I tried to look this up. Wala akong mahanap upon first skim dito. Pero, there's some relevance kasi yung third option mo is export 3D blades into STL format. So you can actually design a 3D printable turbine blade here in QBlade. If walang hanash, like for example, may wala kang gagawing alterations sa weird alterations that don't involve the airfoil shape, pwede ka naman mag-design dito ng blade and um, output it as an STL. So that's one cool thing about this. Pero right now, we don't have a blade pa. So right now, we're just gonna click new. So, oh, okay, what's this? All right. So here's the thing, before we do anything else, let's look at the file. So yung new blade, kaya na bahala kung ano yung gusto niya pangalanan. So I'm gonna label this as the airfoil name, NREL 6268 3 blades. Because we're going to generate 3 blades. So all right. Ngayon, blade numbers 3. The hub radius, if you look at our file, scroll up tayo. Dito na tayo sa details. Details, oh, this is hub diameter pala, sorry. Hub diameter. This is hub diameter. Yung 0.09, that's hub diameter. Wait, let me confirm. Oh, let me confirm yung data that this is. Yeah, yung diameter is 0.09. So, dapat 0.045 yung hub radius. So, hub radius is 0.045. Yan. Okay. So, may warning. Let's ignore it for now. Auto spacing, hayaan natin siya. Tapos, etong dalawang options, we have linear and cosine. Linear and cosine corresponds to interpolations kasi nga nag chop-chop tayo ng mga ng segments of our blade. So we can select linear or cosine. I'm betting that cosine has the better interpolation, pero sa 2011 study, you'll see a claim na nag-linear interpolation lang sila. So let's leave the linear interpolation as is muna. It will result in a medyo jagged blade. Yung taba ng blades, medyo magiging jagged siya. Pero yung pag-twist naman, it will look good. Like, hindi naman junky yung pag-twist nung ating blade, even if linear yung ginamit natin. Tapos, root coordinates, uncheck. Alright. So, uncheck lang natin. Alright. So now, if we ignore the warning, meron tayong tatlong buttons. So right now, I just hover dito sa 0 point. Yung 0.045, yun yung ugat ng ating yan yung ugat ng ating turbine blade. So right now, I have several options. May nire-request na chord, may nire-request na twist angle, may nire-request na foil and polar. So dito, I am going to select base 3 for now. So base 3, ito yung circular airfoil na meron tayo. So ngayon yung polar niya wala kasi wala siya na-generate na data. Yung twist is irrelevant kasi circular lang to. Yung diameter, diameter ng ating circular cross-section is 0.0135. So let's just type that. It's 0.0135. It's getting weird. Okay. All right. So yeah, sobrang weird. Yeah, next, let's put insert after station 1. If we try to insert before station 1, mag-warning siya. Ito kasing ugat nung ating turbine blade. So let's say insert after station 1. Let's put another one. It looks weird. Ano? Sobrang weird. Let's do this linearly para hindi nakakalito. Now we are going to put in base 3. So that's row 3 sa column natin. There's no difference. Ka-copy paste mo lang yung chord, yung twist saka yung base. So this is yeah, as is. Pero yung position, makita natin sa row number 3, yung radial position niya is 0.0075. Oh wait, tama ba? No, this is based to ano. Sorry. That is ano pala. Uh that is not base 3. So, yeah, this is base 3. 0.0225. If you do that, hindi siya nasa ascending order. So that's one warning. That means etong station na to, may diba, like, ito yung thing with QBlade, like, it doesn't like na hindi in order, hindi in distal order yung inyong profile. So with regards to this, I believe you can just delete this. Like, pwede mo nang i-delete tong station na to. Kasi irrelevant na siya. So now, I'm going to go to station 1 ulit. I'm going to generate a different station 2. And I'm going to skip ahead with row number 4. See this one. This row. It's all right. So I'm going to copy this. Wait a second. This is base 3 pala. Sorry. Okay. Yeah. Wasn't looking. Never mind. Tuloy lang si base 3. So this is 0.49. Yeah, okay. So that's consistent na. Okay. Never mind. Erratum sa statement ko. 5.049. Base 2 pala yung tinitingnan ko kanina. So next. So eto, second station mo would be 0.049 si base 3. Yung actual na base 3. Next would be NREL number 4. So, right, NREL number 4. Nice. So, makita mo dito, yung polar na kinukuha niya ay yung 360 na. So, that's good. 360 dapat yung kukunin niya. Next, punta tayo sa number 4. Let's put in the radius, yung radial location niya. So, it's 0.055. 0.055, your chord is, okay, medyo malaki. 0.0495. Then, yung angle of twist niya, it's 38. Alright. Medyo abno pa rin yung turbine blade natin. That's because yung last station natin ay sobrang laki ng cord. Pero don't worry, we'll fix that. We'll fix that later. So, alright. Next. Okay. Punta naman tayo sa number 5. So, number 5. This is number 5. Alright. So, same process lang. Copy. Copy into the radius. Copy the chord. Copy the angle of attack. Tapos, select number 5. Yan. Next station. So, from number 5, dagdag natin si number 20. Yan. So, number 20 is all the way down here. So, this is the radius. Copy lang natin. Parang rinse and repeat lang to, ano? So, most research, if they're actually good, ganito sila ka-boring. Like, you're gonna, like, once you establish yung methodology, puro lang siya, rinse and repeat na lang minsan. That's because kailangan mo ng maraming trials and sometimes hindi siya ganun ka-fun pero that's part and parcel of research. If you have something good, you have to do it over and over just to prove na okay siya. So that's 20. Yung last, yung number 6, that will be our NREL 30. So NREL 30 is all the way down here. Radius niya is 0.4425. Chord is 0.02593. And yung twist niya, oh, okay. Negative, nag-negative siya. It's all right. Okay. Ignore the warning. Gagana pa rin yung simulation natin kahit na hindi siya exactly that. So let's look. Let's look at our work. Oh, okay. Kinda looks nice. Medyo madedetect mo dito eh. Like if you're looking at it from the front, yung linear interpolation mo is very bad. Like, I mean, it's still 30 points, pero magiging halata siya dito. Especially here. Wala kang magagawa. This is section 4 and 5. Like, it still looks bad. Pero if we look at the curve, medyo okay. Medyo decent naman um, yung pag-curve nung angle, nung twist. It's kind of okay. So yeah, we have something that looks like this. So all right. If you're done, wala. Hold on. Bakit ayaw niya mag-save? Kind of weird. Okay. This is a kidding. Ayaw niya mag-save. Hold on. Hold on. Okay. So, para lang magka-file tayo, let's do something weird. Gawin natin number 4 to lahat. Okay, so na-activate yung save. Ba't ganun? I was able to save this kahit na weird yung nangyari sa base. Or I guess, medyo malit naman yung impact dito. So I suppose it's kind of okay. Whoop. Wait, lagyan natin ng 38 para hindi weird. Let's hold the angle. Yan. Okay, para hindi siya weird. Yan. Sorry about that. I don't know, paano napalagpas ni QBlade yung isang extrapolation ko. It didn't happen before sa test run ko. Pero yeah. Again, just to repeat the instruction, station 1 and 2, yung bases, switch to 6268, number 4, then mimic the twist angle. So parang ganito na dapat itsura niya. May effect kaya siya, feeling ko di naman ganun katindi. I feel like yung malaking impact would be dito sa dulo. If something happened here, something will definitely show up on the curve. So yeah, with that, click save. Yan, okay. So yep, that's it. Now you have your blades. So, ano yung tsura nito? Like, what are these tabs? If you deselect show rotor, yung blade lang yung makikita mo. So, okay. It's kind of cool. If you deselect the surface, wala, foils lang yung makikita mo. If you remove the foil out, wala ka na makikita. So, you can do this as well. If you select the trailing edge and leading edge out, makita mo yung outline, essentially. This is the full outline. Fill foils is just, kukulayan mo lang yung segments. Yan lang. So, yeah. Yan na. So far, okay. Kakamusta? Any confusion about dun sa base adjustment? Good so far. Is everything good? Medyo weird lang dito, no? Like, meron siyang, meron siyang discontinuity here, but tingnan natin kung hindi siya, kung, tingnan natin kung madetect ba siya. Either way. Alright. So, yun. Let's proceed now to the last module na pupunta natin, which is the steady blade energy method na simulation. So here, kailangan natin ng kompletong blade before tayo mag-proceed. So before everything, let's define a simulation first. Ngayon, you can relabel as is. Yung mga corrections natin, by default, ang iniiwan lang na unchecked correction is si DTU poly BEM. Leave this one unchecked for now. I've tested this medyo may kita niyo naman kung mas accurate ba siya or mas pangit. So right now, I'm just gonna adjust the wind speed kasi yung assumption na wind speed ng ating study, at least for the first part, nung nag-X-file sila, was that it was running at 10 meters per second. Makita niyo naman sa data though na niiba-iba na lang yung speed. That's all right. Collective pitch, leave this at 0. Ngayon, yung default settings, so baka iba sila. Ito yung default values natin for air. If it's close enough, that's good. So 1.225 for air, kinematic viscosity is 1.48 raised to the -5. Ngayon, yung discretized blade, pwede mo na siyang taasan. At some point, you'll lose, uh, magdi-diminishing returns na siya eventually. Pero si QBlade kasi medyo magaan siya. So, kahit na pangit yung laptop mo, it will still run at this stage. Like, okay pa naman. Convergence, this is the default, pati sa ANSYS. It's convergence at 10 to the -6. Number of iterations, try nyo lang taasan to 1,000 para okay tayo. So, alright. Ngayon. Okay. So, may space na tayo. Here, sa upper left, we have the power coefficient. Dito naman sa kabila, we have the thrust coefficient. Yung relevance nitong dalawa sa baba is not very heavy for us right now. So we can kind of let it slide. May makikita kayong parang weird na color static mamaya. You can look it up kung ano ibig sabihin nito, pero yeah, it's kind of okay. Ngayon, for the tip speed ratio start and end, we specify from 1 to 12. Walang tip speed ratio of 0. Yung tip speed ratio delta is ano lang, yung gaano kapino yung graph na ma-generate mo. So, it's up to you kung okay na sa inyong point 2. Pwede naman i-increase just to increase yung resolution ng curve na ma-generate. So, all right. So, if okay na kayo, set this, if you set the variables correct, but then you can try other settings, especially dito sa baba, that pertains to finite element modeling. So, as long as yung tip speed ratio natin is 1 to 12, yung delta kayo na bahala kung ano gusto nyo. Alright, I'm gonna click. Mabilis lang to. Like, I don't have a timer though. Like, hindi ko ma-measure kung gaano siya kabilis. So, let's start. Boom, okay. Wow, may result na kaagad. Nice, okay. So, what are we seeing here? So, ito yung tip speed ratio. This is it. Meron ka rin tab dito for the tip speed ratio, but this is just the traveling dot. So, if I select a tip speed ratio of 5, it will just travel to number 5. Ito ba dito? If we try to zoom out, so this is the power coefficient curve. Ito naman, This is a thrust coefficient curve. So yes, I can't actually see module. Yep. So yeah, that is it. NN essentially. So let's see nga is parang kaya like wait, let me put it side by side para lang ano. Let's put side by side. Oh, okay. Let's put it side by side. Wait, let me zoom in. May difference. May difference, definitely. Ang question lang is if you refine the mesh or if you refine yung blades, like nagawa mo na yung all 30, ganito pa rin ba yung result? Yeah, that's the mystery. So yeah, ang theory ko ngayon, at least you can have your own ano, although we don't have really the time to test it, pero yung theory ko is that the curve is like this because ang baba nung resolution nung ating blades. So yun isang theory. Second theory, it has something to do with the Mach number. Feeling ko, like, it might have something to do with the Mach number. You can try to run it back to back kasi I would not advise kasi medyo tedious siya. Pero yeah, there is some inaccuracy. Like, kita mo dito, like, the curve predicts a ano eh. Hindi naman siya magdi-decrease, pero like it won't decrease this bad. Like it's decreasing dito sa ano experimental data din. Pero it's very slow. Ito medyo abrupt yung pag-decrease. Ito naman nag-overshoot siya. The maximum power is lower than expected and yung dip niya to zero is too soon. So yeah. I won't ano naman, I won't ask you to ano naman, find the exact answer with regards to that. Pwede naman kayo ano, I'll just let you speculate naman kung bakit ganun yung model natin. So yeah, two things. It's either sobrang baba nung resolution ng blade natin or masyadong may effect yung Mach number. So, alright. Do you have questions pala? Anything that you would like to ask? So, pakita ko lang yung itsura. Like, I was running a different simulation. So, I'll show you. Ito. Tada. So, this is what a partially complete blade would look like. Partially. Tadami pa to. Oh, it's spinning now. What? Can I set it to spin? Whoa, okay. I remember this. All right. Oh, so yeah, if you increase the resolution, yung resulting power and thrust, at least this is for Mach number of zero for most of the blades. I'm not sure if consistent pa rin to. But if you see here, nag-dip yung experimental data natin somewhere close to 11. Not so bad. It's not so bad. At yung red is yung three blades. This green is for two blades pala, in case you're asking. So, three blades lang yung papagawa ko sa inyo. Medyo malapit. The maximum power is close enough. Pati yung thrust curve, it looks a little better. Uh, hindi nga lang niya maabot yung mataas na ano curve. So, it's still underestimating slightly for some reason. So, yeah. This is what a ano, better resolution blade would look like. Something like this. It kind of looks more legit. So if you remove the foil, oh, okay. Kind of looks better. Any questions pala about the activity? So hanggang dito lang tayo sa QBlade. We won't look into the rest of the modules here. This is new territory for me pala. So I don't want to lead you into a territory na hindi ko pa masyadong alam. Any questions? So, okay naman. So yung next submission nyo would just be to reach this this graph, power and thrust. Tapos i-compare natin siya dun sa experimental data na nakuha natin sa ating 2011 study. So, find a way to extract this. Balikan ko kayo kung feel like my way to extract it is just not that obvious. Dito, hold on. Model export data. There's probably a means to export the data somewhere here. So yeah. Yan lang for now. Like before, yung magiging submission date would be very no pressure na submission. Sa Tuesday pala mawawala ako. I'm gonna touch some grass. Tuesday maybe balikan ko kayo. Pero yeah, for now you can use that time to work on this. Medyo it's very simple pero napaka-tedious niya. Yun lang. So yeah, if nothing else, we're good now. Okay na tayo. So yeah, hold on. Ba't ganun? Parang ang baba ng audio ko for some reason. Okay. Hold on. I'm gonna end the recording.